So guys, this video is about BGP and how it behaves on a multi-access network. So BGP behaves very strangely on multi-access networks. Not strange, that's how it behaves. We just got to know what to look for when you're configuring BGP peering, especially BGP peering on a multi-access network. So how do we test this to get a hold of what BGP looks like? What I have here is 4 routers. I've got router 1 and 3 in the same autonomous system, AS13 connected via internal interface in AS13 on E1 and externally on E0 to a multi-access network. Now, this is a multi-access network because it's the same subnet slash VLAN, whatever you want to call, and it's connected to E0s of 2 other routers, router 2 and router 4. And router 2 and 4 are on AS24, internally connected via E1. It's kind of important to make sure that you have a hold of the IP addresses so that it will make sense to you. This segment is 10.0.x/24, of course, and it's .1 for router 1, .3 for router 3, .2 for router 2, and .4 for router 4. So you got this segment as 10.1, 10.0.1, 10.0.3, 10.0.4. That same subnet multi-access on BGP. Of course, like I said, it's configured in the same AS13, and we'll advertise the dummy interfaces on each router and see how it works. Each router has a dummy interface host address with its own prefix, like 1 is 111, 3 is 333, and so on and so forth. 2 is going to be 2222, and so is 4. So that we know how the advertisement is going and how the routing is working. So again, this is AS24. Now we're going to do BGP, eBGP between R1 and R2, and we're going to do eBGP between R3 and R4. iBGP between R1 and R3, and iBGP between R4 and R2. iBGP because it's the same AS, they belong to the same AS, and eBGP because they belong to 2 different AS, 13 and 24. Okay, 1, 2, 3, 4. Make sure we get a hold of the IP addresses. This segment is 13.0.1.3. This segment is 24XX, which is 00.2.4. Pretty easy to remember. E0 router 4 has 4.4s, router 2 has .2s, router 1 has .1s, router 3 has .3s, and 1 and 3 is 13. 1 and 2, 3 and 4 are on the same subnet, which is 10.0.0. Now let's get busy with getting the eBGP and iBGP peers up and advertise our networks and see how the routing is going to look like. BGP would say I am advertising 1111 or 2222 from router 2 to router 1, so router 1 should reach directly to me and vice versa, but let's see what happens. Okay, So let's get busy. I've got two red routers, red windows for the router 1 and 3, and green windows for 2 and 4. So I am going to console into router 1. Oh, it's not running, so I'm going to start the routers, my script. How many routers? I have 4 routers. And what's the prefix? These are R's in my version. Router name would be RTR dash and configure the interface. Yes, let's do that. I'll change the automated the interface configuration, but and here it goes. It's configuring router 1. So this is an expect script that is spawning SSH or consoling into the router and configuring each one of them with the host names and interfaces. Expect is a Linux automation script or shell, very powerful. It's doing router 1 right now, and it's going to do router 2 and 3 and 4. In the while, and I can send you this script if you want it. So let's talk about this while the routers are coming up. So router 1 and router 2. When router 2 advertises its network 222 to router 1, the next hop for router 1 that it's going to learn, because it's pairing with router 2 right here, should be 10.0.0.2, right? And when router 4 advertises its network to router 3, its next hop would be 4444. So the BGP routing is got some preferences. Local preference is the highest, unless this is by default. Then you have the shortest AS path. And if you configure wait, it takes the most precedence, but wait is only configurable on local routers. Local preference, on the other hand, is AS specific. AS path is path specific, and then there's like next hop that we need to look at. So we'll look at these 3 attributes: wait, local preference, AS path, and next hop. How they could be used in a multi-access BGP network in this topology. Okay. So it looks like our routers are up. Let's go and configure. So I'm going to configure with the IP addresses. I just have to do 13 and 24. The others are automatically configured based on their prefixes. So I'm going to do console 1 and show interface. There you go, 1, 10. We're going to eliminate 20 and 30 and put 13. Okay. And then we do 13, show interfaces, same thing. 3, 10 is configured. We're going to eliminate 20 and 30 and put 13 on 1. Let's do that before we go to the other routers. Delete interface Ethernet 1 address, and then just set interface Ethernet 1 address to 13.0.0.1/24. Let's just do this first. Make sure that ping delete interface Ethernet 1 address. Set interface Ethernet 1 address to 13.0.0.3. 3 is .3. Segment between 1 and 3 is 13. Commit run ping 13.0.0.1 is good. Let's quickly get rid of the other one too, which is this. We're not using this. This is part of my script, so by default does that. delete interface Ethernet 2 address. So it doesn't cause any confusion when we're looking at it. Delete interface Ethernet 2 address. So we're done here, and it should be able to ping router 2 as well. Run ping 10.0.0.2 is my router 2, 3 is my router 3, 4 is my router 4. Bingo. Let's go to router 2 and 4. Console 2, VOS, show interface. Let's get rid of the delete interface Ethernet 1 address and set that to address 24.0.0.2/24, and also get rid of delete interface Ethernet 2 address. Commit. 4 VOS configure delete interface Ethernet 1 address and also 2 address, and then set interface Ethernet 1 address to be 24.0.0.4. Commit run ping 24.0.0.2. We're up. So again, going back to the diagram, we just put E24 here, we put 13 here. So we're looking at this. Okay. So let's look at our diagram, make sure we match up. Router 1 has 1111 right here, 13.1 right here, 10.0.0.1 right here, and that's all we care about. Similarly, router 3 has exactly the same thing. Dummy is 333, 10.0.0.3 on 10 segment, 13.03 on this guy. We're good. Let's check 4. 4's got 24.04 on E1. E0, it's got 10.0.0.4 and dummy is 4. Let's check 2. 2's got 2222, 10.0.0.2, and 24.0.0.2. So we're good from an IP perspective. Let's bring up eBGP, IBGP peers. Let's start from router 1, bring up the local IBGP peer first and then eBGP peer first. Next, we're going to advertise the dummy interfaces from Paul. So it's easy for the BGP is easy on, I'm using this guy. I'm using version 118. It's an old one. I don't think you'll find this. I have the copy. If you want, let me know. But the later version of VOS 1.5 BGP configuration is a little more complex than what you're going to see here. So set protocol BGP AS is 13. BGP AS is 13 and 24 down here, right? 13 and my neighbors are 2. I have 2 neighbors, in IBGP neighbor and eBGP neighbor, 13.01 and 10.0.0.2. So my neighbor is 13.0.0.3 and the remote is same, 13. And I've got another neighbor on 10.0.0.2, remote AS is 24. And I need to advertise the network. Network is 1111/32, and I'm done. Let's go on 3, do the same thing, set protocol BGP, AS is 13, neighbor is 13.0.0.1, remote AS is 13, and the next neighbor is 10.004. Remote AS is 24, and I need to advertise my network, which is 3. Need to go do the same on router 2, set protocol BGP, AS number is 24, neighbor is 10.0.0.1, remote AS is 13, neighbor is 24, internal one 4, remote AS is 24, and my network is my router loopback or dummy, and I'm done. And now for 4, the last one, set protocol BGP, AS number is 24, my IBGP neighbor is 24.0.0.2, remote AS is 24, and then my external is 10.0.0.3, and the remote AS is 13, and I need to advertise for. Okay, so now I should have 2 BGP neighbors and 2 BGP prefixes on all routers. Summary will give me the neighbors, 2. Router 1 has 2 neighbors, the IBGP and the EBGP. 10.0.0.2, which is this guy, 13.0.0.3, which is this guy. Same for all others, run show IP BGP summary, 2 neighbors, 2 prefixes, 2 neighbors, 2 prefixes. You still learning? Run show IP BGP summary, 2 neighbors, 2 prefixes, run show IP BGP summary, 2 BGP neighbors, 2 prefixes each. There you go. They're all in sync. Now, multi-access. Show IP. This is router 1. I'm supposed to learn 222 from router 2. 222 is advertised by router 2 internally to router 4 and externally to router 1. Router 1 should learn 222 externally because EBGP is preferred. Guess what? Local preference will take preference. Show IP BGP. Look at this. 2222 is learned through 10.0.0.4. It's also learned through 10.0.0.2, router 2, but it's not preferred. Why? Because local preference takes place. Why is local preference taking place when the router is coming through EBGP? Because, and that's how you check, because this guy is sending this route. Since this guy, so remember, 222 is going this way and this way. So when router 4 gets it, he sends it to router 3. So he gets it, right? He gets it through R4 and he sends it to R1. Now R1 gets 2 routes, one from 3 and one from 2. So that's exactly what's happening, right? He gets 2 routes right here, but he's going to prefer the local preference, which is the default highest priority, since the path length is all the same. And he's not only saying that, he's also saying that I'm preferring this because it's an IBGP internal route. Guess how's that? 10.0.0.4 is this guy, and he's saying this is internal. That's wrong, right? But that's misleading information. That's how BGP behaves on multi-access networks. So to confirm that, prove that he's not learning this route through him, he's actually learning through 3. Do show IPBGP neighbor 1303 routes See that? He's learning 222 through this guy. Even though, again, this is misleading. Next hop is 4, but he's actually learning it from 13 because that's exactly what we said. That's where you can change next hop self. So if I do this, you want to change this 04 to 13003, you use next hop towards 1 and change that. But before that, let's see this. Ping to, I'm pinging 222, right? It's pinging. So I'm pinging 222. It should come directly here. But based on my routes, I'm going to 1004. See that? Very misleading, but that's how multi-access behavior is with BGP. So ping 222, record route. Look, 10, it's going out through 1001, going out through 1001 egress, going to 2404 next egress. Next egress is 2404, which is this guy. 2404 is this guy. So he's going like this, and then he comes to 222. 2404 is this guy, sorry. Yeah, he comes like this and like this, 222, and then goes back to 1001. So this is the route he's taking right here. He's taking this route right here. Going to reach 222, this guy, he's going like this. That's called asymmetric routing. Okay, asymmetric routing. So how do we fix this? First, next hop. Can we do next hop fix so that this guy at least tells me that he's coming? So next hop is again never by default comes from the external transit route. It never takes this guy. That's again a BGP behavior. So to fix this part, the next hop part, again, show IP BGP. 222 is coming from 1004, which it is not. I'm going to fix this. We just proved that by show neighbor routes. I'm going to say set protocol BGP 13 neighbor is 13001, which is this guy. Yeah, 13001. I want to do next hop self. Commit, and then I want to run a reset IP BGP neighbor. Doesn't have the neighbor 13001 soft. Okay. So let's see if this guy changed. Show. And it did. Now it's giving you correct information. So that's one aspect that you need to know, that next hop by default is eBGP egress, not the guy, even though the route is learned through like this, he should actually say next hop is this guy, but he's not. So that's BGP, right? That's just default BGP behavior. And now the default BGP on multi-access is that it takes route like this, path like this. So now you fix the next hop path, but it's still going 1303. I don't want him to go like this. It's still going to do asymmetric. Guess what? It's not even pinging. Why? Because I'll tell you why. 1303 is the next hop for him, right? Show IP route. 1303 is the next hop. So he goes right here. And then when he responds back, right? When he responds back, his path is 24002, which he doesn't know. So you need to provide the transit routes or networks as well. So he's not going to work unless you specify like this. Ping 222 interface my loopback or dummy, which is 111. There you go. Now it works. record route. Now let's see. So he's taking my dummy interface route as a source instead of taking the egress interfaces, going to 10.03, which is this guy again. This is the egress. He goes like this because now we have changed the next hop information. He's going like this, going to 24. Oh, sorry, he's going to 10, not like this. He's going to 10, the egress is like this. He's going through the multi-axis. Now the route is like this: 10.003 egress, 24.04 egress, and then hits 222, and then goes 13.03, which is, then his 13.03 is right there. So at least he's taking a symmetrical route, right? So next hop fixed your symmetry from asymmetrical to symmetrical, right? Even though he is showing you that he's going through 10.03, he's actually going through 13.033. So that's, the information displayed is misleading. So you have to make sure you understand how BGP is behaving right now. So we just fixed this guy for symmetrical routing from asymmetrical. Now, we actually want him to directly come here, not go through all these hoops, symmetrical, asymmetrical, all that good stuff, right? So how do we fix that? So the way we fix that is by using wait. So we're going to set wait. So we're going to say this neighbor is referred to higher wait. So look at this now. Show IP BGP right now. It's going through 13.03, right? That's the preferred one. And look at the wait. Wait is 0. Wait is higher on the local subnets or connected subnets. So the higher, the better. So all the weights are 0. Local preference is 100, still going through inside. So now we're going to set the weight. Configure set protocol BGP so that we fix this so that it goes to 10.02. So this arrow is going to come down now. Set protocol BGP 13, neighbor is 10.0.0.2, and my weight is going to be, let's say, 111. You can set it to 1. Even 1 is going to work. Let's just do 1. Commit, run. Let's just go out. Reset IP BGP neighbor. Neighbor is 10.0.0.2 soft. Show IP BGP. I'm going to have to do it from here. Sorry. Because I have no inbound soft configuration. So I'm going to say reset IP BGP 10.0.0.1 soft, and hard to reset it too, but it'll take time. So now this is going to change to 1. There it is. And now I'm taking, for 2, I'm taking this route. Let's prove that. Ping 10, 222. Now I don't need to do the loop, source it. I need to show that it's actually taking this route, which it is. Goes to 10. Now it's symmetrical and direct. From 10.0.0.1, it goes to 222. From 2.2.2.2, come back to 10.0.0.1. So that's the story of your local preference weight. ES path is pretty straightforward, right? Shortest is better. But local preference by default take preference over ES path. And then obviously the next top part. So if you play with this topology enough, you should be able to understand these basic concepts, and especially when BGP, how it behaves on multi-access. And if you configure this on multiple subnets, like this subnet is going to be one subnet, and this subnet is going to be another subnet, you will not have to do the weight configuration because it's directly going to go to it. This is a classical multi-access issue. Hope this helps.